So these are all simplify the following. So this one here, we have something outside of a bracket, right? So we have to distribute it in until we hit an end bracket. So we're going to get 3 root x times 2 root x, an equal sign. Make sure you have equal signs. Make sure your phones are away. If you have an equal sign, because this simplifies to the next equal, simplifies to the next one. So equal signs are very important. So we get 3 times 2, which is 6. Root x times root x is just x in brackets. Then we get 3 root x times 1, negative 1 root 2. 3 times negative 1 is negative 3. Root x times root 2 is root 2x. And then we have to remember to follow behind with x has to be greater than or equal to 0. Because you have a variable under the square root at some point in time. When that happens, you need a restriction. The next one, we have the 2 out in front. So I told you there was 2 options you could do. You could FOIL first, then distribute the 2 in, or distribute the 2 in first, but stop when you hit an end bracket, right? It disappears. Before I do any of that, though, I should always check and see if I can what first? Simplify. So I have an equal sign again. 2, bracket, 3. The 8 can become a 4 and a 2. The 4 comes out and becomes a 2. Minus root 24 can break down into 4 and 6. The 4 can come out and become a 2. Bracket 2, 18 can break down into 9 and 2. The 9 can come out and be a 3. And then 6 I can't do anything with. So I'm going to rewrite it with all those in front. And I'm not skipping steps, because the moment you skip steps, you often make a silly little error and then get it wrong, right? Which would stink. So, writing 6 root 2 minus 2 root 6, bracket 6 root 2 minus 6 root 6. Now, personally, myself, I distribute the 2 in first, but like I said, you could FOIL then distribute the 2 in. Both are correct. You do whatever works best for you. So, I'm going to distribute the 2 in, but when I hit an end bracket, the 2 disappears, it vanishes, it doesn't keep distributing, right? We have to stop ourselves. So 2 times 6 is 12 root 2, minus 2 times 2 is 4 root 6, and it's still in a bracket because we just inserted the 2 into the brackets, right? The brackets don't disappear until we multiply. And then we get 6 root 2 minus 6 root 6. And then we can FOIL. 12 times 6 is what? 72. And then root 2 times root 2 is 2 in bracket. And then we do outside. 12 times negative 6 is negative 72. Root 2 times root 6 is root 12. And inside, negative 4 times 6 is negative 24. Root 6 times root 2 is 12. And then negative 4 times negative 6 is positive 24. Root 6 times root 6 is 6 in brackets. 72 times 2 is 144. Negative 72 minus 24 more is minus 96 root 12. And we can put them together because they're both root 12s, which we can reduce later. And then 24 times 6 is 24, 12, 144. Yeah. So we get 144 plus 144 is 288. And then I have minus 96 and root 12 I can break down into what and what. We can't forget to simplify if we can at the end. 12 can break down into a 4 and a 3. The 4 comes out and becomes a 2. So I'm going to get 288 and then 200 minus 8, so 192. Root 3. One silly one? Yeah. It's usually a silly multiplication that happens. And then we box it because we're proud of it. I always say box your answer because you're proud. You did all that work. You should be proud of it. You should box it. Be like, yeah, I got this. Even if it's wrong, whatever. Still did some work. Still should be proud. Okay. This one has x is greater than 0. Why doesn't it have x is greater than or equal to 0? Ooh, I didn't talk about this yesterday. What can't your denominator equal? Ooh, yeah. 0, yes. So because our denominator can't equal 0, we can't actually have this equal to 0, right? Because it could make this be 0. So whenever we have a variable in the denominator, no longer is it x is greater than or equal to 0. It's actually just x is greater than 0 because we can't have a 0 in our denominator. It's illegal in all of the provinces and territories. All right, even some states. All right, so we want to get rid of root 5x7, and then we have 45x cubed. But before I do any of that, what did I tell you we should always try and look and see if we can do? Simplify. So root 45x cubed, I can break down into 9 times 5 times x times x times x. The 9 comes out and is a 3, and then 2 x's come out for 1, and they're gone. And then on the bottom, I have root 5. 1, 2, 3, 4, 5, 6, 7. You can do it this way, or you can say, hey, 6 comes out as a 3 and I have 1 left over, right? So it's up to you how you do it. But this can be 1, 2, 3. So I get x cubed out front. So then I'm actually left with 3x root 5x all over x cubed root x. Now, what do I multiply to get rid of my issue? Yeah, just the root x, right? Do I have to worry about the x cubed in front? Is it causing me any problems? No, my rule is I can't have a square root in the bottom, right? And it's a monomial. Today we're going to deal with binomials. But when it's a monomial, you just multiply by what the radical is. So, I'm going to multiply by root x. I'm going to get 3x root 5x squared. Yeah. On the bottom. Well, that's just disappointing. Ah. Good call. This is why I usually do them right after I do them, so I don't miss something. Oh, it's still large. Try again. Oh, this is going to be so pretty. As pretty as math can be. This is going to be super pretty because it's going to cancel them. Could we have just crossed them off, actually? Yeah. We can do this. Sure. Let's try it out. We could do this, or because these are all multiplied together, and only because they're multiplied together and there's no plus or minus signs, right? I could have just crossed them off because they match. Do we want to just do that? I do. Can we just do that? Okay. So these cancel. And then the 3 and the x are still separate, right? And the x cubed. If there was a plus or minus sign in the numerator denominator, I could not be crossing off like I'm doing. That has to be in your head. Because we're going to start getting those right away here. If there's plus or minus signs connecting things, you can't just go canceling off, right? It has to come out of all of them. Remember how I highlighted? That it has to come out of all? Yeah. So this one I can take 1x out of here, and I'm left with a squared. So I actually just am left with 3 over x squared. Which is pretty. Number 4, I can't reduce any of them. I have root 2, root 6, root 6. But I have 3 root 6. Am I going to multiply by 3 root 6? It's a monomial. I only have to multiply by the? Yeah, the root. So root 6. Root 6. So I'm going to get 6 times 1. I put 1 in front here. 6 times 1, which is 6. Root 2 times root 6, which is root 12. Plus 2 times 1, which is 2. Root 6 times root 6 is 6 in brackets. Over 3 times 1, which is 3. Root 6 times root 6 is a 6 in brackets. So I'm going to get 6. Root 12 breaks down into 4 and 3. The 4 can come out as a 2. Plus 12 over 18. So I'm actually left with 12 root 3 plus 12 over 18. Now I have a plus sign in there, don't I? So I can't just go canceling stuff off willy-nilly, right? I said your best bet would even be to highlight all your terms. So there's one term, there's another term, there's another term. Can I take anything out of all 3 of them? What? A 6. A 3 you can. Take out a 3, then you'll notice you take out a 2. Still the same thing, you're just going to do 2 steps. Totally, absolutely fine. So, we can take out a 6 if we want right off the bat. A 2. A 2 is our savior. And a 6 saves you. 2 root 3 plus 2 over 6. And then box it because you're proud of it. Yeah. Ah. Okay. Don't be proud of the previous one because it was wrong. I hope they heard. There. I hope that got heard. It's fine. Number 5. We're adding and subtracting radicals. When we add and subtract radicals, they have to have what? Common radicands, or we can't do anything with them, right? So, 5 root 3 stays 5 root 3. Root 12, I can break down into what and what? 4 and 3. The 4 comes out and it becomes a 2, and that baby's gone. 48, I can break down into 4, but there's a bigger one. 16 and 3. The 16 comes out as a 4, then she gone. And then 75 can break down into 25 and 3. I think I might be starting to get a headache from my slap on my forehead. Viciously, I can maybe not do that anymore. I don't have a lot of brain up here, so leave it alone. Don't do that again. It's okay. I really appreciate you. All right. Actually, I'm starting to get a headache. That's not even a joke. Equal sign. Do you guys have equal signs on all these questions? If you don't, go in and put equal signs, because that is bad. All right. So we have 5 root 3 plus 2 root 3 minus 4 root 3. So many root 3s. Plus 10 root 3. They're all the same. So they're called like terms, just like when you had x's, right? Or numbers without variables in grade 10 in polynomials. So 5 plus 2 is 7. Plus 10 is 17. Minus 4 is, lucky number, 13. Boom. Well, those didn't come out very well in the print off. Is it 3 root 2 and 3 root 6? Okay. So, what is the perimeter? The perimeter, remember, walking around area based on my laying and coming back up with being full of dust. I'm not going to do it again, but that would be like if you covered the whole thing, you know? Good times. Okay, I should teach elementary school. They would totally understand this. Put like a ledge up, fill it with like little fuzzy things. I don't know what. This is why I'm here. Okay, so we have to do the perimeter. We need the third side. The third side is the hypotenuse. And when I don't know the hypotenuse, I just a squared plus b squared equals c squared, but I don't know the c. So we have c squared equals 3 root 2 squared plus 3 root 6 squared. So c squared equals, I square the front and square the root, right? So it's going to be 9, and then root 2 squared is just 2. The square root cancels out. Plus 2 times 3 is squared is 9, and then you square the square root is 6. So I'm going to get c squared equals 18 plus 54. C squared equals 72. Square root. And remember, when you take the square root, you must take the what? What signs go in front? Yes, positive and negative. The only reason, though, that if we didn't write it, we would get away with it is because it's a length, correct? And lengths can't be negative. So you would, luckily, still get it right. But you're actually, okay. So, C equals plus or minus root 72, but because it's a length, C equals plus or minus root 72. But because it's a length, we don't put the minus. Ooh. I'll be speaking faster than I think. 72 breaks down into what times what? Yeah. And it comes out, and it is a 6. So now we have 6 root 2 as our third side. And if we take our little friend and he like, 6 root 2, and then he's going to go, plus 3 root 2, and then he's going to go, plus 3 root 6, right? So he's walking wrong. For those of you who multiply, I don't know what you're doing. Visualize it as like you're a human, and I'm going to take this length, and then I'm going to go this length. I have to add it. And then I'm going to go this length. I have to add it, right? It should make sense. Don't memorize. Yeah. Yeah. So, P equals 3 root 2 plus 6 root 2 plus 3 root 6. And it equals 9 root 2 plus 3 root 6. I didn't make a mistake this time, so I'm going to box it and be proud, even though I was proud of the other ones that were wrong. Whatever. I'm proud of bad things. You can't put them together. Why? Radicands are not the same. That's our rule. It is true. Can you flip to your notes? We left off, I think it's task 4. Last part of division. All right. So, up until now, our denominators have been monomials, correct? Remember what I told you way back when? I said that if we wanted to get rid of a radical when we had a binomial, so we did this before, we'll go root 2 plus 1, and say I want the radical to go away. If it's a monomial, you can just multiply by the radical and it goes away, right? Root 6 times root 6 is 6 in brackets. But when it's a binomial, you have to actually multiply by its conjugate. So remember, we said same thing, but opposite sign in between. And the reason why that is the middle terms with radicals will cancel off. So let's check it out. Let's remember. So this is called the conjugate. Same thing, opposite sign. So root 2 times root 2 is 2. Then we go outside. Negative 1 times root 2 is negative root 2. Then we go inside. 1 times root 2, positive root 2. And then we do last. 1 times negative 1 is negative 1. What happens with negative root 2 and positive root 2? They cancel off. Right? And then we're just left with 1. So when you have a monomial on the bottom, this is when you send home view. If you have a monomial on the bottom, you can just multiply by the square root and it goes away, right? Because root 6 times root 6 gone. When you have a binomial in the denominator and you want it to go away, you have to multiply by the conjugate, which is the exact same thing as a binomial that you have there already, but opposite sign in the middle. That's it. And then your radicals will go away on the denominator. How do you know you messed up? Because when you're done foiling the denominator, if you still have a radical, you didn't multiply by the conjugate. Okay? So our denominator on this one says rationalize each denominator. Rationalizing the denominator means get rid of the radical sign. Okay? Now, root 3 plus 1 is in the denominator. So what am I going to have to multiply by? Its conjugate, which is root 3 minus 1. Just the opposite. So I have to do that to the bottom to get it to go away. And then what was our rule about multiplying randomly to the bottom? You have to do it to the top or you're totally changing the equation, the expression. Okay? So we're going to distribute. When we distribute the top, I have a number in front of brackets. This is why polynomials was so important in grade 10. It taught you how to distribute properly. So we're going to go 4 times root 3. What's that? With an equal sign. 4 times root 3? 4 root 3. That's it. So when you have a number multiplied by a radical, you just get that number radical combo. And then 4 times negative 1? Negative 4. We agree? Now the bottom. We have a binomial times binomial, so we can FOIL. Root 3 times root 3. So 3 in brackets. Root 3 times negative 1. Negative root 3. Root 3 times positive 1. Positive root 3. Which is a good thing, because now they're going to cancel, right? They match. opposite sign. And then 1 times -1 is -1. Now these cancel off. If they don't, you did not multiply by the conjugate. Right? Now everything was a radical and the denominator just canceled off, didn't it? And that's my problem. So on the top I have 4 root 3 minus 4. And on the bottom I have 3 minus 1, which is 2. Now we're using that whole, the very last step we have to do, remember, is we look at every term and see if we can take something out of all of them. Remember I highlighted them? I'm going to use pink. There's one, there's the other, there's the third. Can I take something out of all three of them? What? A 2. Because I don't care what's underneath that radical sign, right? That radical sign's root 3. It's going to stay at root 3 unless I could actually take something out, which I can't. So I can take a 2 out. So 4 divided by 2 is 2. 4 divided by 2 is 2. And 2 divided by 2 is 1. Now, if I have a 1 in the denominator, do I need to write it? No. Because, example, don't write this, 7 over 1 is just 7. We agree? If I have a 1 in the numerator, if everything cancels off the numerator and I'm left with a 1, do I have to write it? Yes. Because if I don't, 1 over 7 does not equal 7, does it? No. So if you have a 1 in the numerator, you need to write it. If you have a 1 in the denominator, you're golden. You can drop it off. So I can actually go 2 root 3 minus 2 here. Box it and be proud. Now, guys, is there any variables in this? You can check these. These are both just exact values, right? They're just not decimals, aren't they? So if you type the top into your calculator and you type the answer into your calculator, what should they both be? Equal, shouldn't they? You're saying this equals this equals this. Shouldn't the answer to this be the same as that? If they're all equal? Yeah, you can check these. Check it out, type it in, see if they match. If they have x's, you can't do it. But if they don't, you can check it. Remember the alpha y equals enter if you have that on your calculator, because then your fractions show up. Once you get them to match, try the next one. Try the try. So this one, we're going to multiply by the conjugate, which is root 5 plus 5. So I'm going to go root 5 times root 5, which equals 5. And then root 5 times 5 is 5 root 5. And then on the bottom I'm going to get root 5 times root 5, which is 5. Outside, root 5 times positive 5 is 5 root 5. Inside, root 5 times negative 5 is negative 5 root 5. And they cancel, which makes me happy, or else I did something wrong. And then negative 5 times 5 is negative 25. So on the top, I'm going to get 5 plus 5 root 5 over 5 minus 25, which is negative 20. And then I look at my three terms, this one, and this one. Can I take anything out of them? A 5. So 5 divided by 5 is a 1. Can I drop that 1 off? Can I drop that 1 off? Let's see. This one's going to become a 1. If I go 1 plus 1 root 5, or I go just root 5, are those totally different? Yes. So I have to keep the 1 in front. This one has to say 1 plus root 5 or root 5 make different things, right? So we have to go through and say, does it change it? So we could go 1 plus root 5. This one can drop off because 1 plus root 5 or 1 plus 1 root 5 is the same thing, right? This 1 can drop, but that 1 has to stay because 1 plus something totally changes it. Correct? And then you can take a 5 out of here and you get negative 4. So it's 1 plus 1 root 5 over negative 4. If you wrote it as 1 plus root 5 over negative 4 and didn't put this second 1, that's fine. But only that one. Then we're going to do B. B has root 2 minus root 3. So I'm going to multiply by the conjugate, which is root 2 plus root 2. Top and bottom. So I'm going to get 15 times root 2, which is root 30. Then root 15 times root 3, which is root 45. And root 2 times root 2, which is 2. Outside, root 3 times root 2 is root 6. Inside, negative root 3 times root 2 is negative root 6. They cancel, which makes us happy. And then negative root 3 times root 3 is negative 3. What's the difference with the top of this one compared to the top of the other ones that we've done so far? We can still simplify, and we're going to have to. So root 30, can I break that down into anything? 4? No. 9? No. 16? No, we've gotten too big now. So root 30 still stays the same. 45? Yeah, I can break it down into 9 and 5. And the 9 comes out and it's a 3. So this can be 3 root 5 all over 2 minus 3, which is negative 1. Now, is there anything I can take out of all of them? I have a 1 in front, a 3 in front, and a negative 1. No. So this answer is correct, but it probably won't be there. When you just have a negative 1 in the bottom, they'll often bring it to the top and distribute it through. So this negative 1 can go to this number and to that number by division. So instead of leaving the negative 1 on the bottom, what they'll do is they'll bring it up here and then distribute it through. So they're going to get negative root 30 minus 3 root 5. And then no denominator, because the denominator would just be positive 1. If you don't believe me, type that in, get a decimal. Type that in, get a decimal. They'll match. They are the same thing. You guys are going to try the try. What's different with the try? The numerator has 2 terms this time, so you're going to have to FOIL the numerator as well, not just the denominator. Okay, so try the try. So I'm going to get 2 times 2, which is 4, root 2 times root 6, which is root 12, 2 times 1, which is 2, root 2 times root 5, which is root 10, then negative 1 times 2, which is 2, negative 2, sorry, root 6 times root 6, which is 6 in brackets. And then last one, negative 1 times 1 is negative 1. Root 6 times root 5 is root 30. Over. You have to be able to do these on the test. There will be these ones where it's a binomial and a binomial. Then we go, 2 times 2 is 4. Root 6 times root 6 is 6 in brackets. And outside, 2 times 1 is 2. Root 6 times root 5 is root 30. Inside, 2 times negative 1 is negative 2. Root 5 times root 6 is root 30. And then negative 1 times 1 is 1, negative 1, sorry. Root 5 times root 5 is 5. And these cancel, which is ultimately what we needed to go away, right? Then on the top, if we can, or after this, if we can simplify something, we do. On the top, the only one we can simplify is root 12, right? So I'm going to go over here and do it, just so I don't have to like, do it in that big thing. So 4 root 12, I can break down into 4 times 3. The 4 can come out as a 2, and it's 8 root 3. So you can show your work off to the side and not throw out this big, long fractional thing, right? You can go off to the side and show that, and now I can go in and go, okay, this works out to be 8 root 3. It still stays 2 root 10, I can't reduce it. This is minus 12, and this is negative root 30, can't reduce that. And on the bottom, I get 24 minus 5. So I'm going to get 8 root 3 plus 2 root 10 minus 12 minus root 30 all over 19. Now I have 5 terms. 8 root 3, 2 root 10, 12, minus 1 root 30, and 19. Can I take anything out of them? 19 is a prime number. Nothing actually comes out of 19, so we're done. Page 290. Once again for the 700th time. It's the last lesson in this part. Number 10, 11 ACD. (13 and 14).